Hello everyone. Today I'm going to talk about effects of the temperature and food quality on age and size at maturity in ectotherms and experimental tests with Atlantic salmon. And first, we have to know what is maturity. And the figure is life cycle of Atlantic salmon. And when salmon can release sperm and eggs, that is, they can have babies. So we can say the fish is matured into adult salmon and is in its maturity. And when will Atlantic salmon attain maturity? This will affect by the somatic resource or somatic energy. And what is somatic resource? You can see this as the total energy that you can use to do something like sexual character. Because the fish has to grow up, so they have to grow their sexual character to become an adult salmon, or migration, or courting, or parental care. So there must be a relationship between body size and amount of reserve energy and age at maturity. And in 1994, two scientists, Vivian and Cydney, they suggest that ectotherms mature earlier at larger size when growth rate is increased by high food quality, but they will at smaller size when growth rate is increased by high temperature. And this is because the puzzle, because a few scientists can explain this. And in recent studies, we found that body size decreased because of climate warming, but some species have no influence of temperature change. So, in this study, we want to know the relationship between growth rate, age, and size at maturity as temperature or food quality change. So, we expect to see if we increase temperature and increase food quality, it will increase growth rate. And if we increase temperature or food quality respectively, increased temperature will reduce size at maturity, but increased food quality will increase size at maturity. And last, if we increase food quality, it will decrease age at maturity. So in our experiment, we use Atlantic salmon, and we sample 20 males and 23 females from river inside in Norway. And we let them mating and have little larvae. So little larvae, 100 fish of spring, they will divide into 8 groups randomly. And in this figure, there are 8 fish. And each fish will represent as one group. So there are 8 groups. The first 4 of them will live in ambient water temperature. And I will call it low temperature later. And another will live in ambient water temperature plus 2 Celsius. And later I will call it high temperature. And each temperature group, 2 of them, we will feed them higher lipids. So I will call it high quality diet later. And another will feed lower lipids, and I will call it low quality diet later. So there is a relationship between percentage of mature salmon and treatments. The x-axis are 4 treatments. HT is high temperature, NT is low temperature, HL is high food quality, LL is low food quality, and the y-axis is sexual maturity, use percentage. And the solid line is males attaining maturity during the second year. And the broken line is females attaining maturity during the second year. And the dotted line is males attaining maturity during the first year. Okay? So you can see, first we see the dotted line. Is males attaining maturity during the first year. We can see it's higher in high temperature plus high food quality. Later we see the solid line. Males attaining maturity during the second year. There is no significant difference between 4 treatments. And we see broken line is females attaining maturity during the second year. It's higher in high food quality plus high temperature, and lower in low temperature and low food quality. And we compare body mass and treatment. In this third study, we use body mass as size. So also, we see the dotted line is males attaining maturity during the first year. There is no significant difference between 4 treatments, but you can see it's smaller than the other. And we see the solid line is males attaining maturity during the second year. It's higher in high food quality. And we see the broken line is females attaining maturity during the second year. And there is no significant effect by diet treatment. And last, we compare growth rate and age and size at maturity. The practice is we practice by using Bergen and Carnot puzzle. And observe is the experiment. So first you can see the growth rate. In high quality diet is high, and lower quality diet is low. And can see if growth rate is high, and the age and maturity is young, and also its size is small, which corresponds to the puzzle and our purpose. So we can say that both temperature and feeding conditions influence maturation, and higher temperature plus higher food quality will have higher percentage of maturation. And if we compare same age fish, you can see in high food quality, they will have larger body size. Low food quality will have smaller body size. And if we increase growth rate by increasing food quality or temperature, it will decrease age and size in maturity, but there is no significant effect of temperature alone. It must combine with high food quality. So this is my presentation. Thanks for listening.
June, please.
She wants to know the detail about age and size. In our experiment, we about that if the salmon attains maturity in young age, and its size will be smaller. And if we attain maturity in older age, and its size will be larger.
Lilian.
Can you explain again about somatic results?
She wants to know what is somatic resource. Somatic resource just like the total energy that you can use. The salmon needs to do many things like eat and will grow up, or migration, or courting, or parental care. So the total energy is constant, but it has to do many things.
Cydney.
If you had to egg fish, what is normal temperature in this room?
Repeat.
What is normal temperature in this room?
Repeat her question.
She wants to know what is normal temperature. In our experiment, we count 30 meters depth from river inside, and the temperature is plus like this. This solid line is normal temperature, and the broken line is the normal temperature plus 2 Celsius.
Janice.
Can you back to the somatic resource? I want to know what is the difference of courting is eating and parental care is have the children. Is that
She wants to know what is difference between courting and parental care. And courting is a fish like another, so they will go into dating. And parental care is if they have babies, fish daddy and fish mommy will take care of the baby.
Jack.
I really want to know these factors combination with growth rate.
Repeat your question again.
Why do they know these factors connect with the growth rate?
Repeat this question.
We want to know why they want to know the factor to
Repeat your question again.
Why do they want to know these factors have
This factor means which factor?
food quality and temperature? high neck with growth rate.
Growth rate.
Growth rate.
Okay. Do you want to know why food quality and temperature connect with growth rate? And one is they are based on the 3-year study, and they want to know because this is the question. We don't know how change between food quality and temperature. So in this study, we want to actually know when food quality or temperature change, and growth rate will how to change.
Alisha,
What is the difference between low and high food quality?
We want to know what is difference between low and high food quality. And high food quality is at higher lipid percentage, and the lower food quality is represents lower lipid percentage.
Ethan,
How to know a fish age?
again, what's your question?
How do you know a fish age?
We want to know how we know the fish age. They measure it, and they didn't know the actually age. It was to distinguish adult and not adult. So they use sexual maturation to differ salmon.
I think overall it's a very good talk. The main weakness was you couldn't make 10 minutes. So first of all, you could see that her introduction was actually very nicely made, so full of images, so it's easy for you to read and you feel comfortable reading the slides. And then she came up with a very clear purpose slides, although I think this should be reused again in conclusion. I will tell you later. And then her talk speed was also very nice, so you don't feel like in a rush. She was talking very calmly, but I think you could talk more loudly. And then you could see that the artwork was also nice. Although I would say artwork is not necessary, but it's always good to have good artwork. And then regarding the results, in fact, when I was reading the paper yesterday, I feel that this figure was actually not that easy to read because it has this high temperature, low temperature, high quality, low quality, and so on and so on. And first year maturation, second year maturation, you get confused at the end. But she was able to guide you through the results very calmly, and she was not hesitant to repeat again what this symbol meant, what that symbol meant. So it makes her presentation of the result very easy to follow. That was the good thing I saw in her presentation. And although I think because you talk about this first year, second year maturation, so I would say since you still have time, you should put this slides next time in your material method. So you can just say that the experimental duration lasts almost 2 years. So you may have salmon mature in the first year or the second year. So that would happen. Otherwise, when I was when it came to the results, then it was a little bit abrupt that suddenly they are first year and second year issues. So it would be good to tell the audience. And then regarding this one, I generally prefer that you can remake the table yourself. So not just paste it. And then, actually, that was probably a weakness of this presentation because although now we understand that this is a comparison of prediction and observation, but what was the general conclusion regarding whether your observation matched the prediction or not? So maybe you say that, but that kind of message would be the key message from this kind of comparison. So it would be good to give us a concluding remark somewhere to tell us what the audience think, or what the authors thought, whether their results match the prediction or not. And then, in general, the results were really nicely presented. However, given these kind of different combinations, I start to lose track, especially at the end of the conclusion. It was like, oh, I cannot really recall which data support this and that. So in general, there are some ways to enhance the impression of your conclusion. The first way is to recall your purpose. For example, you can make your purpose as questions. And then in your conclusion, you print your expectation or something. And then you tell us whether your results match your expectation or not. That would be something very essential for this talk. Because at the end, I don't know if your result match this B something expectation. Does it? Does it match this puzzle? All right, so you can tell us next time because I was really confused. So I don't know if the results match the expectation or not. And if not, which part does not match the expectation? That will be the first thing to enhance the impression of the talk. The second possibility would be, so some of your 学长学姐, they have done that. So, for example, you can, when you present this conclusion, you can make a mugshot of your result figure. Mugshot means a thumb. 这是缩图啊. You can put the thumb of your result figure and say, okay, these results support this, to enhance the conclusion, but you don't really need to explain the whole figure again. You just say, that figure supports this conclusion. So these are two ways to improve your conclusion. First is to answer the question you wrote in your purpose slide. The second is to add a thumb of the data figure in your conclusion to say, okay, this data support this conclusion. That's something I think you can do and improve your talk next time. But overall, I think it's a very nice talk, so let's thank Vivian.